So, uh, good morning and welcome again for the lecture of electronics. Here, today we are going to study another topic of electronics, which is very important in the field of biomedical instrumentation. I guess you understood biomedical instrumentation. Biomedical instrumentation means the biomedical potentials, or say the biomedical small voltages are being measured uh, by using the electronic circuit. Right? So that particular instrument is called as the biomedical instrumentation. For example, if you need to measure temperature, you need to measure blood pressure, right? You need to measure the oxygen level. So these all instruments which are involved in this are called as the biomedical instrumentation part. Now, in some cases, what happens, we are having very small voltage, right? So when we have a very small potential, then we require a amplifier which is going to amplify at a larger size. So if you have a voltage say around a microvolt, then it is to be converted into millivolt, or it may be converted further into voltage, right? So to for the doctor or the for the prescription, say pediatrician, to actually analyze what type of signals and at what type of signals he is going to get. So for that you require that type of amplifiers which are being amplifying the signals at a very high scale. Right? So those amplifiers are called as instrumentation amplifier. Now let us start with my presentation. I guess here. I guess my screen is visible to you all. Is it visible? Is it visible now?
Yes, sir.
Yes, sir.
Thank you. So keep me updating because I need to know. So let me introduce myself. Myself, Dr. N.D. Mishra. I'm Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science, Nagpur, Maharashtra. So today we are going to study about the instrumentation amplifier. Instrumentation amplifier means the amplifier which is going to amplify the say very small signal. Right? Those are called as instrumentation. Uh, I request everybody to kindly mute themselves. So, starting with that, what is a difference amplifier? This is what we have studied, right? So, we have already studied what is a difference amplifier. So, amplifier, op-amp as in subtractor. Yes. इसका साउंड शुरू है कोमल इससे बता प्लीज थोड़ा सा okay, so I guess the screen is visible to you all. Let me share this. Yeah. So we were studying this. What is an difference amplifier? So op-amp as a difference amplifier. In that we are going to amplify the difference of the inputs applied to the op-amp, right? So in the same sense that op-amp actually is going to give you the difference of the input that is being given to both of the inputs to that. So that is why it is called as a difference amplifier, right? So it is going to give the difference of the inputs, right? Now, what is the difficulties that we are having in that is it is having an infinite gain. So whenever we are not using the op-amp in closed loop gain, then it is going to give you infinite gain. So infinite gain means बहुत बड़ा gain, बहुत बड़ा मतलब इनफाइनाइट नहीं होता है एक्चुअली जितना भी आप लोग सप्लाई उसको देते हो पावर सप्लाई देते हो उसके हिसाब से उसका आउटपुट वोल्टेज आता है. So if it is plus minus 12 volts, then the output is going to switch between positive plus 12 and minus. Uh, so the op-amp itself is a differential amplifier in nature, right? So one must devise a closed loop configuration which facilitates this operation. So we have discussing this. So this is actually the difference amplifier, which I mean to tell you that we are having two voltages, that is V1 and V2, which are being applied to this inverting and the non-inverting terminal of it, and the output is supposed to be the difference of these inputs. That is why it is called as a difference amplifier. In the another words that we have studied is op-amp as an subtractor, right? In that case also we are using the same. So it is going to subtract and give the output. So VO will be equal to V2 minus V1, right? So V2 minus V1 will be the output of this. So that is called as the difference amplifier. So this is what we are going to use. Now, yeah. So the single op-amp difference amplifier is going to give you this type of output. So V out is equal to R2 by R1. These are the input and feedback resistances. V2 minus V1. That is what I said. So it is going to give you the output difference of the inputs. This is what we have studied in semester 3. So op-amp as subtractor, right? So that there is some shift in the notation. Now, initially, earlier we have used that A is supposed to be the open loop gain and G is supposed to be the closed loop gain, right? Now we are going to use that parameter A is an ideal gain of an op-amp and the parameter G is not being used over here. So we are going to use only A as the notation. So don't get confused in that. The instrumentation amplifier. Now, what is the problem which is associated with the difference amplifier is it is having low input impedance. Now, what is impedance? Remember this. What is an impedance? Impedance is nothing but the input resistance of the amplifier, right? Means whatever resistance we are going to apply to the input side of that circuit, that is called as the input impedance. And as far as the say the maximum power transfer theorem says, maximum power transfer theorem क्या बोलता है? जब भी दो सर्किट्स का रेजिस्टेंस मैच होता है तभी इनपुट वाला सर्किट आउटपुट वाले सर्किट को पूरा का पूरी एनर्जी उसको दे सकता है. Okay, so whenever the resistance or the impedances of both the circuits are going to match, then only the maximum power is supposed to be transferred, right? So अगर मैं इसको आउटपुट सर्किट बोलता है तो जो भी इनपुट रेजिस्टेंस हम लोग अप्लाई करने वाले ये सर्किट का इनपुट इम्पीडेंस, तो ये सर्किट का इनपुट इम्पीडेंस कम होना चाहिए, ये सर्किट का इनपुट इम्पीडेंस ज्यादा होना चाहिए, so that they should match. Most probably, maximum power transfer theorem says that both the input impedance should be same, right? Both should be same. Then only the maximum power is being transferred, right? So this the problem of difference amplifier is it is having low input impedance. अगर लो इनपुट इम्पीडेंस है तो उससे कम इम्पीडेंस आउटपुट इम्पीडेंस वाला ही सर्किट हम उसको चॉइन कर पाएंगे. दिस इज द मोस्ट ड्रॉबैक ऑफ द डिफरेंस. So this is what is explained over there. So what should be the solution? So the solution is placement of two buffers at the input terminal amplifiers which transmit the voltage level but draw minimal current, right? So अगर हम लोग ये input impedance अब बढ़ाने के बारे में सोचते हैं, ये difference amplifier का input impedance हमको बढ़ा, तो अगर ऐसा इनपुट इम्पीडेंस अगर बढ़ाना है तो हमारे को दो सर्किट्स लगाने पड़ेंगे जिसका इनपुट इम्पीडेंस ज्यादा हो, जिसको हम लोग बफर एम्पलीफायर बोलते हैं, बफर एम्पलीफायर, राइट? सो व्हाट इट बफर मींस which is going to match the impedances. So those amplifiers are called as buffer amplifier, right? इनपुट इम्पीडेंस आउटपुट इम्पीडेंस समझता है कि आप लोगों को कोई प्रॉब्लम है किसी को तो मुझे अभी पूछो तो मैं आई कैन एक्सप्लेन यू इन डेप्थ. Are you getting it? Hello, anybody can unmute and let me know. Hello? Hello? है क्या कोई सब सो रहे हैं?
Yes sir.
आयुष, हाँ
Yes
बताओ
sir.
मुझे.
नहीं.
इनपुट इम्पीडेंस पता है क्या? बेटा इम्पीडेंस पता है क्या आपको? क्या होता है?
हाँ सर.
नहीं.
रेजिस्टेंस.
हाँ, वेरी गुड. रेजिस्टेंस होता है. वेरी नाइस. तो रेजिस्टेंस ऑफ अ सर्किट, राइट? रेजिस्टेंस ऑफ अ सर्किट हम लोग उसको बोलते हैं. तो हम लोग सर्किट का इंपीडेंस मैच करते हैं, रेजिस्टेंस मैच करते हैं, राइट? दो सर्किट्स होते हैं, राइट? एक होता है हमारा इनपुट सर्किट और एक होता है हमारा आउटपुट सर्किट. फॉर एग्जांपल एक मेरा पास एम्पलीफायर है और एक मेरे पास स्पीकर है, राइट? तो स्पीकर इज सपोज टू बी द आउटपुट सर्किट, राइट? और इनपुट सर्किट क्या हो गया? अपना एम्पलीफायर. अब ये दोनों का इम्पिडेंस या ये दोनों का रेजिस्टेंस जब तक मैच नहीं होगा तब तक के हमको आवाज जो है वो क्लियर नहीं आएगी। दिस इज द बेस्ट एग्जांपल ऑफ दैट, राइट। सो आवाज क्लियर आने के लिए हमको क्या करना पड़ेगा, इसका आउटपुट इम्पिडेंस, एम्पलीफायर का आउटपुट इम्पिडेंस जो होना चाहिए वो कम होना चाहिए या इक्वल होना चाहिए हमारे स्पीकर के रेजिस्टेंस या इम्पिडेंस के साथ, तभी अपने को सुंदर आवाज सुनेगी, राइट। ये समझा क्या आपको? सो दैट इज इम्पिडेंस। So whenever we talk in terms of resistance of a circuit, then it is called as the impedance of that particular circuit, right? So we are having two impedances, one which is called as the input impedance and the other one which we call it as the output impedance. So circuit जब हम लोग input side में लगाएंगे तो that circuit will have output impedance। जिस सर्किट को हम लोग ये सर्किट लगाने वाले हैं तो उसको हम लोग बोलेंगे इनपुट इम्पीडेंस। सो वी आर हैविंग दीस टू सर्किट। Remember this, impedance is nothing but the resistance of a whole circuit, right? So that is called as impedance. So impedance या resistances of the circuit should match with each other। जब तक वो मैच नहीं होंगे तब तक के मैक्सिमम पावर ट्रांसफर नहीं होगा, राइट। सो फॉर दैट अब हम लोगों ने डिफरेंस एम्पलीफायर देखा, डिफरेंस एम्पलीफायर समझा हमने। डिफरेंस एम्पलीफायर क्या देता है, दोनों इनपुट वोल्टेजेस का डिफरेंस। अब हम लोग क्या कर रहे हैं, क्योंकि उसका इनपुट इम्पीडेंस लो है, हम लोग उसको दो बफर ये लगा रहे हैं, एम्पलीफायर लगा रहे हैं। एंड इससे हम लोग और क्या ले सकते हैं, सिर्फ मैचिंग ही नहीं होगी, इससे हमारा वोल्टेज गेन भी बढ़ेगा। अब वोल्टेज गेन क्या होता है, अगर मैंने इनपुट में 10 millivolt का सिग्नल लगाया, रिमेंबर दिस, जस्ट लिसन इट वेरी केयरफुली। when I applying 10 millivolts input to a circuit and I say that the gain of that particular amplifier is again 10, right? इस एम्पलीफायर का गेन कितना है, 10 का गेन है। मैंने इनपुट में कितना दिया है, 10 मिलीवोल्ट दिया है, राइट। तो मुझे आउटपुट में कितना मिलना चाहिए, 10 इंटू 10, 10 जो गेन है वो मल्टीप्लाइड बाय 10 मिलीवोल्ट, तो मुझे कितना मिलेगा, 100 मिलीवोल्ट मिलेगा। सो दैट इज कॉल्ड एज अ गेन, राइट। गेन मतलब अब आउटपुट वोल्टेज और इनपुट वोल्टेज का कितना डिफरेंस है, right? So additional voltage can be obtained by using this circuit, right? So that is, now this is the circuit of an instrumentation amplifier। अगर आप इसको थोड़ा सा देखें तो you might be able to see these are two buffer amplifiers that we are going to attach now here, right? Yeah. So this is that uh, two buffer amplifiers we are having over here. So this is one and this is the another. Now these are going to provide you the high input impedance, and this is the same circuit as we have attached here, that is a difference amplifier. So we are having now three op-amp circuits. One is the buffer amplifier, second is another buffer amplifier, we are applying the input voltages over here, and then the difference amplifier in the third stage. So the total circuit is going to give you the instrumentation amplifier, right? So let us see what are the characteristics of this. This is stage one, right? In which we are having two non-inverting op-amps, A1 and A2, which are going to give you the output voltage as 1 plus R2 by R1 into V in V1 and V2, right? And stage two is actually a normal difference op-amp amplifier, which is going to provide you with another gain that is actually equal to A3, right? Additional. So this additional. So we are having two stages, right? Stage one, which are two buffers, and the stage two, which we are having it as a difference amplifier. So this is how, see, while teaching on board, I might not be able to tell you this circuit in that depth, which I am able to tell you right now. So this is actually a very nice presentation. Uh, so this is actually going to tell you actually what is going on, right? So what I told you, this is actually the circuit of an instrumentation amplifier where we are having two op amps, two buffers, and the third one is actually the difference amplifier. And this is we calling it as a stage one, which we are having two non-inverting op-amps, A1 and A2, which are going to provide you the output as 1 plus R2 by R1 into V in, right? And the difference amplifier, which is again going to provide you with the output voltage equal to R4 by R3 into V difference, right? So V difference, whatever with the difference of these two, we are going to get. Now again, uh, this amplifier is going to give you not simply going to give you the impedance matching, but also you are going to get the additional voltage gain. That is what is the importance of this instrumentation. That is what we are working on. So the additional voltage gain is being provided by this formula. That is V out equal to R4 by R3. Now this whole formula is actually the transfer function of instrumentation amplifier as shown in that figure, right? And this is the additional voltage gain. So R4 by R3 into 1 plus R2 by R1 into V difference, right? So whatever the difference of voltage we are having over there is going to get. So the total, in total, we are going to get the additional voltage in that. That is the glimpse of that instrumentation amplifier. These are some of the advantages of instrumentation amplifier. It is having very high input impedance. Yeah, so it is having very high input impedance, uh, high differential gain, then symmetric gain, we are having gain. You, I guess you understand what is gain now. So it is providing in high input impedance, high differential gain, and high symmetric gain. I'm going to tell you on this what is symmetric, and these are some of the disadvantage of this instrumentation amplifier. So if the gain of differential amplifier, difference gain and the common mode gain are equal in the first stage, that is the most drawback of this. I'm going to tell you this in depth in coming slides. So ADI and ACM, that is the difference gain, differential gain, as well as the common mode gain, are equal in the first stage. This is the drawback of that. So in first stage, both difference gain and the common mode gain are same. And sorry, I'm sorry. So differential inputs and common mode gain are being amplified, which are supposed to be equal, right? So what happens in that? So I'm going to tell you. So this is what I mean when I say what is the problem of ACM with A equal to A. So common mode gain and differential gain, right? So here, if I think in that pattern, so if differential mode gain is greater than the common mode gain, we are having two situations. One in which I am going to consider that here we are assuming that differential gain is very, very greater than common mode gain. And here we are going to uh, assume that differential gain is equal to the common mode gain. Now, what happens with that? Let us see. So if we take the first case, that is differential mode gain is greater, is very, very greater than common mode gain, then what we will have? So if suppose V in is equal to, that is the input voltage is equal to 10.03 volts, and V in 2 that will is equal to nearly equal to 10.02 volts, right? And a gain of 10 into 25, that is the gain of this buffer amplifiers, and the difference amplifier is equal to 10 into 25. Then we'll be having this output. So V out will be equal to 250 into 10.03 minus 10.02 volt. So it is a difference of that. So we might get output will be equal to 2.5 volt, right? So just it is equal to zero point 0.1 volt, right? The difference of it. Now let us take with what happens if we are having a differential gain, right? So if we have a differential gain equals to common mode gain, then what happens? If we are having this 10.03 volt and this as 10.02 volt with a gain of 10, so we'll be having this as 15 volt, this as again as equal to 15 volt, right? And since we are eliminating the decimal portion of it, so we'll be having the output over here. So we'll be having two gains. One will be the gain of these buffer amplifiers, and the other one will be the difference amplifier. So here we are having a problem. V out equal to 25 into 15 minus 15 volt. Right. So 15 minus 15 is going to give you 0 volt, and which will be nearly equal to the output will be equal to 0. Right. So this is a problem with when we say that differential mode gain is equal to common mode gain, right? So the both the buffer amplifiers goes in saturation. Saturation means what? They are going to give the infinite voltage, high voltage, right? So they are going to give as much as the power is supplied to this op amp. The power is supposed to be 15 volts, so it will be more. The output will not be reached more than that. So 10 into 10 is going to give you 100. But since it is being since it is being restricted to only 15 volt, so plus minus 15 volt हम लोगों ने इसको power supply दिया, तो 100 volt कहाँ से पहुंचेगा? That's why 10 into 10 is going to give you 50 volt. That is saturation. Saturation मतलब वो 15 वोल्ट के ऊपर जा ही नहीं सकता क्योंकि उसको पावर सप्लाई ही 15 वोल्ट का दिया, राइट? तो अब बाय डिफॉल्ट हमारा गेन जो है वो 10 का होने की वजह से, और हमने 10 वोल्ट 10 इनपुट दिया है, तो इसको 100 जाना चाहिए, 100 जाना चाहिए, बट इट वोंट गो इन 100, बट इट विल गो इन say 15 volt. That is saturation. So 15 volt over here, 15 volt over here, and if you have a difference of that, then we'll have a 0 volt over here. This is the problem, right? So that is why we require this differential gain. So the instrumentation amplifier again can have these type of say disadvantages again. So the first disadvantage was this: if it are equal in first stage, meaning that common mode and differential inputs are amplified with equal gain. Now, need for matching. If two op amps, this is second drawback. If two op amps which comprise stage one are not perfectly matched, one will see unintended effects. तो ये जो दोनों बफर एम्पलीफायर जो हम लोगों ने लगाए हैं, ये दोनों के दोनों मैच होने चाहिए. रिमेंबर दिस, मैचिंग ऑफ एम्पलीफायर्स इज वेरी इंपॉर्टेंट. मैचिंग मीन्स व्हाट? मैचिंग मीन्स उनका जब भी हम लोग मैन्युफैक्चरिंग करते हैं तो उनको वही सेम कंडीशंस पर मैन्युफैक्चर करना चाहिए, सेम कंपनी ने करना चाहिए, सेम कॉन्फ़िगरेशन के साथ करना चाहिए, सेम रेजिस्टेंस, सेम पेयरिंग, सब कुछ सेम होने चाहिए. बट ये प्रैक्टिकली पॉसिबल नहीं है. इवन इफ द सेम कंपनी इज गोइंग टू प्रोड्यूस द सेम आईसीज, still there will be manufacturing defect and there will be no matching over there. So that is the second drawback. Since we are not having perfectly matching between the two op amps, that is the second drawback of that. So how can one fix this, elevate these advantages? So if there is, so again, I'm going in depth, though we are not expected to write this much. We are expected to write that instrumentation circuit only, but this can also be achieved by just say just replacing that R1 and R2. So remember this. This was the circuit of instrumentation amplifier. This is only what is required in your syllabus. But I'm telling you in more depth that how this can also be that disadvantage can also be decreased, yeah, reduced, right? So that can be reduced by just replacing this R1 and this R both R1s and replacing it with a single circuit like this. So if you do this with only twice of R1, then the second disadvantage, that is of matching of amplifier, can be uh, optimized, right? Uh, we have any? What is symmetric gain? Okay, that's what I'm telling you. Symmetric gain means you can unmute yourself and ask me. Don't worry. No need to chat with me right now. Right? What happens? Symmetric gain means when both the amplifiers are being manufactured by the same company, same brand, and the same structure, same internal combination. What happens? Still, there are some defects, and both the op amps will not be able to match with each other, right? So that is called as symmetric gain, right? Symmetric gain means whenever we are applying the same type of configuration to an op amp, we expect same type of result to come out of it, राइट? ये ओपैम एक और ये ओपैम दो, ये दोनों ओपैम में अगर हम लोगों ने सेम कॉन्फ़िगरेशन लगाया, सेम रेजिस्टेंसेस लगाए, तो हम लोग एक्सपेक्ट करेंगे कि इनके आउटपुट में भी हमारा जो रिजल्ट है वो सेम है. बट सम सिचुएशंस में क्या होता है, ड्यू टू देयर मैन्युफैक्चरिंग डिफेक्ट, ये बोल सकते हो आप, मैन्युफैक्चरिंग डिफेक्ट के वजह से हमारा आउटपुट जो है वो सेम नहीं होता, कुछ तो भी डिफरेंस होता है. इवन आपको पता है कि ये रेजिस्टेंसेस भी आप लोगों को कुछ ना कुछ वेराइटी देते हैं, वेरिएशन देते हैं, राइट? इसलिए हम लोग उसमें कौन सा इफेक्ट है 10% ये लेते हैं, राइट, प्लस माइनस 10%, तो उसका रेजिस्टेंस का भी वेरिएशन रहता है, रेजिस्टेंस भी वेरी होता है, right, depending on the situation, depending on temperature, depending on the pressure, depending on the circumstances, surrounding conditions, ये सब पर हमारे resistance भी vary करते हैं. Similarly, we won't expect the same type of output to come. So for that, we can use this type of circuit where we are replacing this by a simple twice of R1, right? And then we might have a little bit of say symmetric, right? So this can be analyzed by that. And how can one analyze this circuit? So this is same like that. So stage one will have the current flow like this. A1 and A2 will be V plus minus V1 is equal to 0. If both are equal, then if you put over here, V in difference will be by 2R1, right? That is the current that we are expecting to flow through that circuit. And because no current will flow into ideal open, all of IR1 will flow across R2. So the current is going to flow from this uh, ये IR2, यहाँ से current flow होने वाला है, that is what is shown over here, right? So the output of A1 and A2 will be equal to V in minus I1 R2, V out will be equal to V in plus I1 R2, and then yeah, like this. So all of the current is going to flow, and this is short circuit. Short circuit means no current flows through this uh, because it is having high input impedance. So current nahi jayega isme se. So the all the current is going to flow through this twice of R1, that is IR, right? ये यहाँ पे ये arrow से show किया हुआ है. And the current is going to flow from R2, and we will be having uh, the V out one and V out two like this. So it is very very effectively shown how the current is going to flow. I will show you again. Let us see. Yeah, this is how the current is going to flow. These are short circuit, and yeah, again it is going to show. Yes. This is what the glimpses of say while we are having the presentations, these are the effects that we are not able to show you on board. This is how the instrumentation amplifier works, and this is again the derivative part of it, so we won't land in that. The last equation that is more important is V out minus V out 1 will be equal to 1 plus twice of R2 by R1 into V into, right? And the total output gain is going to give you like this. So V out by V div is equal to the differential gain, that is equal to R4 by R3 into 1 plus twice of R2 by R1. And this is supposed to be the total gain that we are expecting across the instrumentation. So I guess you have understood this instrumentation amplifier. Thank you very much for joining this class. And if you have any queries, so I will be happy to answer you. So do you have any questions on that? Thank you very much for joining. So I'll just again we can say repeat that. Yeah, we can repeat that for you. Okay. Wow. Shavini is joining now. Right. So we were working on instrumentation amplifier, right? So we have studied the difference amplifier, what are its structure, and what is the drawback of this. This is actually a difference amplifier, or we call it as op-amp as subtractor, right? And these are the characteristics of op-amp as a difference amplifier. Then this is the output which is shown over here. Uh, then these are some of the notations that we are expecting to use over here. This is instrumentation amplifier, and the problems which are associated with the difference amplifier is low input impedance, and that means the source impedance will have an effect on gain, right? So source input per circuit is the source input, and this is the input impedance of that circuit. And the solution is two buffer input amplifiers can be used, and that may provide additional voltage. So this is the circuit that we are supposed to use. That is uh, the two buffer amplifiers over here, one and two, and this is the difference amplifier. And this is stage one, this is stage two. Here, this is going to provide the non-inverting op amp A1, A2, and this is going to provide you the additional differential, right? And this is the additional voltage. So not only the impedance matching, but additional voltage can also be optimized by using this instrumentation amplifier. These are advantages. This is the one of the drawback that can be removed. I guess this that can be removed. This ADI ACM are equal in the first stage. This can be removed by this. So if we are having a differential mode gain is greater than common mode gain, then it's okay. If both are same, then we are going to have a zero output. So it is having no problem over here, right? If differential gain is very greater than common mode gain, and here we are having problems since it is going in saturation. Since all the buffer amplifiers are going to be in say saturation. Therefore, we are going to supposed to get zero output voltage. The another drawback is the need of impedance matching, right? And this can be achieved by just replacing these two resistances by twice of R, right? This can analyze the circuit, and this is the derivation of the output circuit. And this is how the current is supposed to flow through the circuit, what I've shown. And the last output voltage is going to be the revised instrumentation amplifier gain is going to be this gain, right? So ADI is equal to R4 by R1 plus twice of R2 by R. I guess this is okay for today. So if you have any problems, kindly let me know.
No, sir.
So thank you very much for joining and stay tuned. Please be attentive on this class. Hopefully, we'll be starting again by say transducers portion. And yeah, we have completed this paper with this of ITM Nagpur University semester 4 electronics paper 1, right? So we have completed the syllabus of paper 1 almost, and we'll be trying to take one exam on this paper 1, right? So objective will be there. So let us try, and I will let you know when we are going to take that exam, right? So thank you very much for joining. Be attentive, stay tuned, stay home, stay safe, take care, and see you soon in the next class. Thank you for watching this video also. Thank you. Good day. Take care. Bye.